And now let's go to the last reactor in the ideal reactors section, which is the yield reactor. And for me, the yield reactor is the most useless reactor that you can find in this whole the whole types of the ideal reactors. I'll tell you now why I find it useless. For all the other reactors that we defined, let's just say that this is the product of the yield. For all the reactors that we defined, we had to define something that is logical and get something output. The output product or the product that we get is logical, either to define the reaction or to define the or tell him from the thermodynamics that I need to do something. You need to get the equilibrium composition, you need to get the equilibrium constant or the heat of reaction. So these are some information that are useful information and are logical, and you can find a theoretical meaning for these terms that you get. But for the yield, it is the most illogical reactor that I could think of. Again, let's take a look and see how it works. So I'm operating at temperature 75 Celsius and the pressure of 75 bars. And what I'd expect from the yield, that I will tell him that I have two reactions, and the yield, if this is the definition of the yield that we know, and the yield of the desired reactor, the desired product to the undesired product is this. And this is what I would expect. But what I get from the component yield is not what you'd expect. So again, if I say that for ethyl acetate, I get 100 moles at 70 moles as a base. You can define the inert components, but it's not gonna make anything. And if you run the file, this is always what you're gonna get. So this is the first thing to mention, that the yield reactor always gives errors. And I'll go through this quickly just to see what is the problem. So if you go to the yield, it tells you that some normalization has been made and that some elements are not in atom balance. And I don't think you'd find this error of the atom balance error in any other block in Aspen Plus except in this. And take a look at the if I take a look at the phase equilibrium, it's not going to be any use for the balance. It's not going to be, and the weird thing that you could find it is only ethyl acetate, and we have 4 components. So it's very weird that you have 4 components and only the X and Y's and the K for one single component. Where did the other components go? And this is the magic that happens here. And this is not magic, it's very weird. First, you'd find that the moles is not consistent. The number of moles in is not gonna be the number of moles out. And this is strange, because the reaction that takes place always takes 2 moles and produces 2 moles, so the number of moles should be always consistent. So this is the very first time in the ideal reactors to find the reactor that changes the total number of moles. And if you take a look at the output, it is very strange. So what it did, it removed all the reactants and put them here in the ethyl acetate. And just to understand the way it works, it just tells you, I'm gonna make the mass consistent. So it just makes sure that the mass is conserved. So the mass in equals to the mass out, and that's it. So you told it to give you the output as ethyl acetate, then it gives you the output as ethyl acetate. For instance, if and you might be you ask a question, why did I put the yield of 70? It gives me a different number. The only reason, if you put water, for instance, then if you put 30, it's gonna put give you the output of water and ethyl acetate with this ratio. So again, it gives you an error, and for the stream results, this is what you're gonna get as the mass fractions, or the mole fractions, I'm sorry. It's 30 and 70, and that's all. So it doesn't do any reactions, it doesn't give you any output that is meaningful, it doesn't do anything meaningful at all. there is one thing that is, I don't know. For instance, if I define delete the ethyl acetate, just I want you to remember the reaction. I'm gonna go here. The reaction occurs between two molecules. Each one of them contains two atoms of carbon. So I have here two carbon atoms. We have here two carbon atoms. So by no means the output can be only water. So you have to have a compound here, either ethyl acetate or whatever component that contains carbon, because you have carbon, a lot of carbon in the feed. So if you do this, it means that you have components. The yield of water is, or the two components will react to produce water, which is nonsense actually, but it can do it. So it gives you an error, again the similar, and that's why I put the yield reactor at the end, because it's going to give you an error each time you run the file, and I don't want to see the error every time when I'm working. So again, the results is not going to be of any meaning. For the balance, it tells you it generated some moles because it has to make sure that the mass is conserved. For the phase equilibrium, it's only water. And for the stream results, it is gonna give you, and this is the magic, it's all water. And I don't see that this reactor is useful by any means. And this is what you'll see in most of the textbooks, or all the textbooks that I read, that talk about Aspen Plus. They just mentioned that there is a reactor that's called yield reactor, and they never go through it, and because it's not of any physical meaning to put something like this. It's a magic thing that is not present in the actual life. So that's all for the ideal reactors. These three reactors, the CSTR, the plug, and batch reactor, are gonna be the topic of the next videos, inshallah. So I'll see you then. Goodbye.